Morning, class. So, you guys hear me? Someone confirm.
Yeah, I can hear you.
Okay. So, according to the schedule, we're not teaching today. It's a review for the exam tomorrow. So, hopefully, you guys have questions. And you can open your mic, ask questions, or let me in the chat room if you have questions. There's multiple people have questions. This whole situation has messed up my sleeping hours, so woke up at night. It's terrible. Okay. Let's get well. Did anybody try to join the office hours yesterday? Meeting during office hours? No? Schedule. After exam one, 0.7, 8, 9, 4, 9, 6. Okay. Well, guys, I'm waiting for questions. Can you do the one, our last quiz about work? Was it the cone? What was the last quiz? I think we skipped quiz. Who's asking? Alex? I already emailed. Sections 8.7, 8.8, 8.9, 9.1. You guys don't read emails, do you? One, two, three, four, five, six. So actually, this one is 9.1 all the way to 9.6. So that's what kind of exam cover. So I'll email you and emphasize, but in terms of the exam, I gave an exam for differential equation yesterday. That class has 39 people and 38 people took it. And you people just came up with, dumb excuses, although I had given them extra 10 minutes. So I'm going to do the same for you guys. The exam is only 50 minutes, so that means you should be able to do it in 50 minutes. Even if you're not able to do it in 50 minutes, make sure you stop it at the 50th minute and you use the extra 10 minutes I give you for, the uploading process, scanning it with your app, making it PDF. Make sure you name it, your name, first name and last name, if not just first name. And let me explain again. I'm downloading all these files in one single folder. Okay, so if it is very easy if it's already named your name, whereas I have to change the name for every single file. Okay, and make sure it's scanned readable. So the 10 minutes that you have, right at the 50th minute, you start scanning, making a PDF, check it yourself, make sure it's readable, make sure all the pages are scanned, and then email it to me. I'll accept no excuses if you don't submit it by the end of the hour. I'm giving you a total of 60 minutes. Use 50 minutes to respond and write your answers. And then that 10 minutes to scan and submit. So exam is 10 to 11. I'll post it on e-learning, and the file opens at 10 a.m. like at 100. And so you get the PDF, write your answers on different pieces of papers, 8 by 11, no line paper. I mean, you're done to scan it and email it. Any questions? That feel free to open your mic and ask questions.
Could you go over improper integral problem?
Sure. Okay, let's start with the cone problem that it asks. So it says tank has the shape of inverted circular cone. So okay. The length or the height of this cone is 10 meter. The radius of that is 4. Okay. And it's filled 2 meters away from the top. So this portion is empty. And this portion is a water. So this portion, water. Okay. Now it's asking the density of water, or delta. Delta density is 1 kilogram per liter. Okay. Delta. So, okay, find the water required to empty the tank by pumping all the water to the top. So that means we want to move all the water to the top, and then from here, it's just gonna be pumped out. Yeah. So the way we did it, in fact, the picture suggests what you have to do. since you know the weight of the water on top is different than the bottom, and then the tip in the bottom, the weight of the bottom is zero because there's nothing, right? Single point. Whereas in the top, you have a bigger disk of water, so you need more work, or it weighs more basically. So for that reason, you choose a disk of water with the thickness of dy or dx, it doesn't matter. Also, let's go ahead and assume choose this point as the origin. So that's y equals 0. Okay. And this is y-axis. That distance is y. That means how far do we have to move this up? That distance, which is 10 minus y. All right, let's write down. So dw, the element of work, because you're only calculating a small portion of the work, whereas everything. So dw is this small portion of force times distance. So our distance here is 10 minus y. Okay. And df is mg 10 minus y. Okay. And to be more accurate, we should write dm, an element of mass, right? So d is not separate, variable. It's the d of f. It's like d of x in integration. So this is mass. This whole thing is force. This guy is work. Okay. Now, what is dm? Is the element of volume times density, right? So it's going to be g is constant. So let's pull that one out. Let's start with that. Delta times d of volume. So this is volume. And then 10 minus y. Question so far? Now, equals. Delta was 1, so let's get rid of that. That's only g. All right, now let's figure out volume of that disk. So we have a disk. Right? The radius is r. And the height of that is dy. So volume of that is going to be the area of the circle, which is pi r squared, times height dy, 10 minus 1. Right? And in this expression, y is changing, also r is changing. Eventually, we want to integrate, so we want an expression in terms of one single variable. That's why you go ahead and set up that right triangle. Where you have 4 here, that's the big one, 10 here. That's y according to your picture, and this is r, right? So you're going to have, so r over y is the same as 4 over 10. So that r is 2/5 times y. There you go. Here you can substitute for that. So g pi. So r was, in terms of y, 2/5 y squared, 10 minus y, and dy. So this is the work done to move only that disk, that little disk, to the top of the cone. Now we have to do this for all those disks, right? Except radiuses of those disks is going to change as we move up and down. Questions so far? Okay. I have my chat open, so if you have questions. Now, you go ahead and integrate. So the total work is the integration of that expression, g I, which is constant. Let's square that. We get what? 4 over 25, right? Then y squared is y, dy. Now question. I'm integrating from what to what? What number to what number? Anybody? Yes, with respect to y. 0 to 10, 0 to 8. So which one is correct? 0 to 10 or 0 to 8? 0 to 8. Is it full all the way? No, it's not, right? Only, like the highest level of water that we have to is that point right there, which is at 8. So it's 0. Good. All right, now let's go ahead and integrate. So this whole thing is constant. Hold out. So g I 4 over 25. Let's distribute that y squared, so we get 10 y squared. dy 0. I know it down. So g 4/25, 10 y cubed over 3 minus y fourth over 4, right? 0 pi. If you plug 0, you get 0, so we only care about 8. Let's simplify this because we have an 8 to the 4th. Let's see. So g pi 4/25. So I'm going to pull out the biggest power of y that can be factored out, which is y to the 3rd, and at the same time, go ahead and plug 8, so it's going to be 8 cubed. Now, rest is 10 over 3 minus 8 over 4. And you can simplify that. That's what? 16 over 12 inside is 4 times 10, 40. 3 times 84 is 24. So what is 40 minus 24? That's 16. So 16 over 12, just simplifying to 4/3, right? Although I don't care, so you can leave it right there. The number at the end is the least that matters. 4/3. Uh, that's, what is 8 cubed? It's 64 times 8. Uh, 4, no, 5, and multiply that by another 2. And only, oh, we have to multiply by 60. Okay, never mind. Never mind. So it's 2 times 8 to the 4th over 70. Of course, g is 9.8 or 10. Doesn't matter. The number at the end. This process, what I care is up to this point, guys. So that process. Okay. Even if someone leave it right there, it's okay. You don't have to simplify the numbers. Big number. Okay, any question on this? Or we start doing a proper integration, open mic, ask questions on steps. Process that. Good? Okay. No, Alex, you said improper integration. Do you mean specific example? Do you have certain question? Hello, Alex. Alexu. Oh, 1 minute. No problem. 1N and proper. One N. Hold on a minute. Improper integration. 7. 1N. Okay. Is it the one that says 2 to infinity and then the fraction 5z plus 1 over z squared minus 1? Easy. Okay. This is 8.7 1 n 1 n is the integration 2 to infinity 5z plus 1 over z squared minus 1 equal. Okay. Is it obvious that it's improper? At least because of that infinity? No. Is there any other point from 2 infinity that we have to worry about? Is there any number between 2 and infinity, 1 and infinity that make denominator 0? People are saying 1. You're not wrong. It's 1. In fact, there's another one that make denominator 0. Negative 1. But are any of them in this interval 2 to infinity? The answer is no. I mean, we're good. We don't have to worry about denominator. The denominator of that fraction is not 0 on the given interval of integration. Okay? If this integral was from 0 to infinity, would have been a different story. You would have split it up into 2 integrations, 0 to 1, 1 to infinity, and then for each, you do separate improper integral. So in this case, we only worry about infinity. Okay, that's one single thing. So we do the limit, interval 2, let's call it a, 5z plus 1 over z squared minus 1, easy. Now a approaches positive, right? Now, at the moment, let's focus on finding the antiderivative of 5z plus 1 over z squared minus 1. Okay. So, but, in fact, let's go ahead and only focus on finding the antiderivative of 5z plus 1 over z squared minus 1. Right. You have to use a technique. Of course, we don't know the antiderivative of this. There's one single shot, top of our head. So we have to use techniques we learned in chapter, was it 7? What do we use? Partial fraction. Right. Okay. So for that purpose, we have to did, you have to factor the denominator. What is it factor to? So 5z plus 1 over z square minus 1. It factors 2. What is it factor to, guys? Beautiful. Z minus 1. Okay. No. Let's partition it. Let's decompose it to give it up to 2 fractions, right? Z minus 1, z plus 1. Now, what kind of expressions are we expecting? What do you put up there? A and B in top, indicating constants. So we're looking for 2 constants, A and B. I don't know, it could be 1 or 2 or 3 or whatever. So that the sum of these 2 eventually will be that guy right there. Okay. So write down partial fractions. All right. Let's continue. So what was the next step? We multiply by the common denominator. Common denominator is this whole z squared minus 1. So if you do that, z squared minus 1, which is just z minus 1, z plus 1. Both sides, right? And if that happens, as you can see, the denominator of that one way, so z plus 1 on that side, you get a times z plus 1 plus b times z minus 1. Right? Okay. Again. Good. Oh, put the next call. So then we let me write that again. So we had 5 z plus 1 equals 8 z plus 1 plus b times z minus. All right. And it's clear what numbers you want to pick, right? So z equal 1. So if z equals 1, then on the left side you have 6 equals b term is 0, so you have 8 times 2, that means a is 3. Z equals minus 1. Then you have negative 4 equals, a term is 0 this time. It b times negative 2. B is 2. So that 5z plus 1, z squared minus 1 is 3 plus 2 over z plus 1. And it makes sense. Think about it. If you add these two fractions, 3 times z plus 2z is 5z. 3 minus 2 is 1. Get 5z plus 1. Okay. Now let's, so now we can, integrate. And integral of 5z plus 1 z squared z is the same as integral of 3 over z minus 1 plus 2 over z plus 1. Easy. And what kind of integration are we dealing with? ln natural log. So we have 3 log of absolute z minus 1 plus 2, right? Natural log of z plus 1, right? Okay. We don't need a constant because eventually we do indefinite integral. So one comment I want to make, if you want to put these two natural logs together, of course you can, right? Especially if this was a subtraction, you would do want to do that because sometimes the limit of that is a finite number, whereas you might think is not a finite value. So if you wanted to write this as, natural log of z minus 1 cubed times z plus 1 squared, putting them together, well, feel free to do that. Since, first of all, the 3 goes as the powers of each two same, and then since it's plus becomes a natural log of multiplication. Any question on that step? No. All right, let's move on. So what do we have? We had the limit, thus the integral 0 to infinity, not 0 to infinity, 2 to infinity. 2 to infinity. 5z plus 1. Easy equals the limit. Make a infinity. So we evaluated the integral, which is this expression up there. To a. So if you plug 2, you won't get 1, so that becomes 0. So you get 1 cubed, that's 1. 2 plus 1 is 3. 3 squared is 9. So you get a natural log of 9 for the second term. And then the first term, plug a, so we get the limit of, natural log of a minus 1 cubed, a plus 1 squared, right? Natural log of this whole thing, minus natural log of 9. And a approaches infinity. Oh, if there was a negative, Lena is asking, it would be a division. So if that was a negative, it would have been natural log of z minus 1 to the third divided by z plus 1 squared. It would have been a natural log of ratio. Okay. All right, guys. Now we have to take limit of this as a goes to infinity. So what do you think is going to happen? Basically, where is this term approaching as a approaches infinity? Infinity is the answer. And since natural log of 9 is almost nothing, right? To take away from infinity, this whole thing is infinity. So what's the conclusion about the integral? Therefore, integral 2 to infinity 5 z plus 1 over z squared minus 1 dz, as Alex says, divergence. That's it. Questions?
Where did the minus natural log of 9 come from?
That's when you plug 2 to the expression.
Okay.
Right. Anything else? Okay. What else? Volume of an object and decide what method to use. Yeah. So I give you a region revolves about certain axis. Now you pick if you want to do washer, disk, or what was it? Shell. And remember, we did an example, like same solid, but both methods, and you saw one was maybe even just a little bit simpler than the other one. But sometimes you get an integration where the integral is way easier than the other methods. That's what you decide. Sometimes in one of the methods you get an integral that is like hardly doable. It's almost switch your method to different. Right? Anything else? Let me give you an example. Actually, I'm going to give you a problem so you work on. Consider yeah, let's consider this. This is e to the x. Okay. No, it should be to the negative x. Or x is increasing. What am I? So this is e to the x. Okay. From 0 to 1. Now this revolves about the y-axis, this region. So it's going to make it solid. Okay. So region R revolves about y-axis. Find the volume of this solid. So for this example, you do it later. Maybe you do it during office hours, and then you can ask questions on it. Shell is way easier than disk on this one. So choosing your stripes this way makes it more. It's going to make it more simple than choosing it this way. You can try it on your own and see the difference. So I'll write it down. Shell better than disk. There are so many examples. That's the one that just came to me. Like, in fact, let me tell you, when you do shell, eventually get an integration that you still have to do one by part. Like you have to do by part once. If you do disk, it's not even doable. Okay. Anything else? Do find, assuming you're talking about numerical integration using Simpsons or trapezoid, then find it better, right? Fine. And then we give you all the equations. Yeah, I'll give from here. Actually, I won't give it. But those formulas, you can look at your textbook notes. I use them, okay? Remember, the problems I'm going to give you is not going to be, way different than the ones we have done so far. The notes on exercises at the end of each section. But it's not going to be very difficult, and it's not going to be exactly the same. You know what I mean? So I've changed the numbers, make it different a little bit. So if you know how to do those ones, you should be able to do this one. And let me say something else. Do not waste your time on anything else. So literally assume or just imagine you're sitting in the classroom as we did for quizzes and the first exam, me walking around, sort of proctoring. And then you just guys focusing on your own exam and doing it. If you waste one single minute, that's 1 minute of the 50 minutes that you have to take this exam. Just focus on the exam. Go somewhere in your home. I don't know if you're in the dorm, somewhere quiet, and just take the exam. Do not think about anything else. Nothing. It's not a take-home exam where you have 1 or 2 days. You only have 1 hour, and you need 50 minutes. Probably you need 30, 35 minutes. Just if you knew all the answers, you would need 20 to 25, maybe 35 minutes just to write, like nonstop write. Now imagine if you have to think about questions too. So any questions? Okay, let's do what happens if you have technical difficulties for some. Make sure that won't happen. I guess you pray that it won't happen. Are we gonna be in the WebEx when we take it? No, I won't watch. I see. I've heard some other instructors do that, but they use different app software to monitor their students as if you're locked down in prison. Someone is just monitoring you for an entire hour. I think it's creepy. I don't like that. Okay, let's go find a approximate integration. write down these two formulas. So the error term, which one should we do, Athena? So you'll just email it at like 9:55. No. On e-learning, on the Dropbox, there's going to be an item called exam 2. You can't open it until the clock hits 10 a.m., like 1 and 1000, okay, 1000 tomorrow. As soon as that hits, you're able to see a PDF called exam2.pdf. You open it, and if you want to print it out, print it. If not, just open it on your laptop right in front of you, and then start answering on different pieces of papers, 8 by 11, not line. And when you're done, again, make sure you have a clock on you, clock in front of you. You only do this for 50 minutes. You should be able to do it earlier than that. Like if you know all the problems, you know how to do them, you know the methods. If you write non-stop, you should be able to do it in 20 minutes. Okay. But make sure you stop at 50th minute and you spend the next or the last 10 minutes on scanning, making a PDF, and then email, submitting it to Dropbox. There's going to be, Dropbox for that. Submit it there. How many pieces of papers? I don't care. But preferably, make sure it's organized. Make sure it's clean. Make sure, it's not all over the place. Make sure your work is readable. And when you scan it, you check your own scan. Make sure it's readable to me. I have to grade your scanned work. Okay. Not too much light, not dark enough. Not dark, not too light. Yeah. So if you want to use one page for one answer for each question, it's okay to me. Or if you want to, so the question 1 answer, draw a line, separate it. Question 2, draw a line, go like that. I prefer the answer of each question on different piece of paper. So use one page to answer question 1, page 2, answer question 2, 3, and like that. Okay. So that if you switch between question, let's say first you answer question 1, then you want to go to question 5. Okay, then you wouldn't have, in not a normal order, because I don't want to add grade 1 and then go 5. So you do it the answer of each question in a different piece of papers, and then you can order them at the end. All right, let's do. We only have 5 minutes. Here's a formula. Athena, which one should we do? Trapezoid or Simpson? Simpson was a better Simpson, because the order of the error has with the 4th power of n or 5th power of the interval is different. So the error of Simpson is less than equal. Call it m, right? You can call it m sub 4. B minus a 5th over 1a. Right, let's go pick one problem. So again, M4 is the the smallest number satisfying this inequality. So you take fourth derivative of the function. Remember, we're doing this assuming we want to find this integration. Integral of f of x a to b dx, right? Where this function has no antiderivative, or it's very hard to find the antiderivative. Then, so we approximate using Simpson's trapezoid. So this m4, m sub 4 is a number, is a positive number, smallest positive number satisfying this inequality. That it has to be an upper bound basically for the fourth derivative, right? And if you have noticed, for you guys, only give polynomial function. So you take the derivative of 4 times, at the end you get a constant. So that constant is basically your m. Okay. In reality, I have to give you a function that is not eventually, the fourth derivative is not constant, and you have to figure out an upper bound for it, like what's the maximum minimum using the optimization techniques you guys learned in calculus. So anyway, let's say I want to find the smallest n, the number of intervals, so that for this integral, let's say 0 to 2, and this function, x to the 5th plus 4x cubed minus 11 dx, the error term is smaller than 1 over 1,000 using Simpson's method. Okay. So, you're going to have to call this f of x plus 4x cubed plus 11. And you start taking derivative because you need the, let's change this to 4, by the way. So let's change this to 4, x to the 4th. Because x to the 5th is going to create a function of x. So we said 4. X to the 4th minus, I do have 1 in this x cubed minus 11. So f prime, as you can see, is 4x cubed minus 3x squared. F double prime is what? 12x squared minus 6x. F third derivative is 24x minus 6. And eventually, fourth derivative of f is 24, which is our m sub 4. This guy. Okay. I'm going to go to the next page. And so, as you can see in this setup, in this formula right there, the one that I'm circling, m sub 4 is going to be 24. E minus a, you already have it. B is 2, and 0 is a. And you figure out n, where this whole thing has to be less than equal, or less than strictly 1,000. I'm going to go to the next page. Okay. 40th. So m sub 4, let me write it down, b minus a to the 5th over 180 and to the 4th. This has to be less than 1 over 1,000. Okay, so 24, 2 minus 0 to the 5th over 180 n to the fourth should be strictly less than 1000. And now go ahead and add up this inequality, solve for n, right? What can we cancel out? I think we should be able to cancel some numbers between them. 24. This is divided by 6 becomes what? 30. And this divided by 6 is 4. I can still cancel the 2 in it, right? So 30 divided by 2 is 15. 4 divided by 2 is 2. Okay. Now, 2 to the 5th is what? 2 to the 5th is 32, and that one is 64. 64 over n. Fourth is less than 1000. Now, so we get n to the fourth is bigger than 64 times 1000. Right? Now you want to take fourth root of both sides. So we get n is bigger than fourth root of 64. Our thing is, does it have a fourth root? 64 is what? 2 to the 6, so it's 2 to the 4th times 2 to the 2nd. And that guy is 10 to the 3rd. So n is bigger than 2, and then 10 to the 3rd has a 2 and 5 in it. So it's 2 to the 3rd, 5 to the 3rd. This becomes 2 to the 8th. That means 2 to the 2nd comes out. Then we get 2 times 5 to the 3rd. Now this has no nice fourth root, right? So for that one, we can use a calculator. Figure it out. Can someone take a fourth root of, what is it, 250? Fourth root of 250. Or 250 raised to 0.25 or 1 over. Give me a number like 2 decimals, 15.9. That's fine. And let's go ahead and multiply that by 4, please. 15.9 times 4. 63.6. So this is 63.6, almost. So approximately this is 63.6. So your n should be bigger than 63.6. So you're looking for the first integer. And you have to be careful here. What method are we using? Simpson. What was the requirement on n for the Simpson's method? Oh, you mean the whole thing is, Reno, you mean the whole thing is 15.9? Yes, okay. So it's okay. This is 15.9. Thank you. And who said even has to be Donovan? Yes, this number has to be even. So what's the first even number bigger than 15.9? 16 it is. So n is 16. And what does this mean? I mean, we're done, but the meaning of this number is that if you wanted to approximate that initial integration that we had, x to the 4th minus x cubed plus 11 dx, using Simpson, you would have to divide this interval 0 to 2 to many intervals. What's the smallest number of intervals on which, if we do Simpson, we get an error, or our approximation is very close, is as close as, it's only differs by 1 over 1,000 from the exact value, is 16 intervals. So you would have to divide this to 16 intervals, at least. Of course, if you do larger number of intervals, your approximation gets even better and better. But for the purpose of having over 1 over 1,000 error term, We only need 60 minimum. Any other questions, guys? Do you suggest using simple scanner to scan or test? I mean, on my phone, I have the, what is it called? Camera scanner, but I've had it for a long, long time. I don't know if I paid for it at some point, so I can still scan for free. But it seems like the camera scanner is not free anymore. It lets you do 3 or 4. So I think, yeah, the Genius Scan is for iPhone. I think it's free. But for Android, simple scanner, I have it on my tablet and it's free. Simple scan. I mean, it doesn't hurt to, just today, take a few minutes, 10 or 15 minutes, and then just scan a few random things and see if you are able to quickly put it into PDF, then email it. Yeah, Ryan, I think it's the case for other people, so it keeps dodging fate. But does it let you do still, scan for free? Oh no, it has to make a premium version of it. Okay. It's not hard, to find it. But the thing is, don't do it the last 2 minutes of that 60 minutes that I give you. Okay? So start early. Start at 50th minute. Stop the exam. So start doing it. If it doesn't work, at least you still have 8 or 7 minutes to figure this out. Is there a faster way? I don't know. I mean, I'll just email myself a document after I scan. I do the same. So I share it with email, and then email it to myself, and then I open that email in my computer, and then I do whatever I have to do. And if there's a faster way, I'm not aware of. All right, guys, let's take a break. Does anybody want to stop? I mean, stay for the office hours? Asking questions? Type yes in the chat if you want to stay, or if you have questions. Stick around for the office. All right, no staying. Okay. So, let's do a 5-minute break. Fill my teacup. Yeah, you can stay. I mean, everybody can stay. You can just keep your mic off in case you have questions. You can ask. Okay. I want to stop the session right now and post the video and the notes.